Hello and welcome to our Friday video. So we've just taken a quiz. We've covered some good ground looking at quantitative variables and how to start analyzing them. Now we're going to move on to starting to look at relationship between variables. So this is where I think things start to get kind of fun, and hopefully you find it interesting and helpful. So we're going to start thinking about having more than one variable. We've already seen that, right? We've seen multiple variables in data sets that we've worked with, including the one we generated ourselves. We've also seen multiple variables when we've done time series plots. So when we look at how a quantitative variable is changing over time, that's actually two variables, right? We've got a variable measuring time, and we've got whatever thing we're looking at, a price of a stock or something. And so we're actually looking at a relationship between those two variables if we're looking at how something is changing over time. Now we're going to be interested in a lot of different relationships between variables, so we're going to spend some good time on it. We're going to start by looking at two variables, and then we're going to kind of build up from there. And as I've foreshadowed, we're going to build some simple predictive models. So we're going to use linear regression to come up with models that help us try to understand relationships, try to be able to control for things that we think may be affecting what's going on, and we want to be able to set them aside to focus on something else. And with predictive models, we'll see that that's actually kind of the foundation for a lot of the stuff that these big tech companies, Google and Facebook, they're using these sort of models to, say, I think that you'll be really interested in buying these new glasses. I think you may be interested in buying clothes from this particular brand, right? They come up with all these suggestions and targeted ads based on these sort of predictive models. And they have some really fancy models, but really at their root, a lot of the stuff that they're using is stuff that we're going to learn how to do even in Excel. So that's coming before too long. Now, today, it's going to be a fairly short video, and we're going to just kind of start thinking about the relationship between variables and what that may mean if we find there is a relationship. And so you'll hear this now and you'll hear it going forward. There's something we'll talk about called correlation, and that's when we find that there is a relationship between variables. Now there's a saying that correlation is not causation, or correlation does not mean causation. Causation is a relationship, a particular type of relationship, where we can say that one thing causes another. I let go of these and it causes them to drop. And gravity causes them to accelerate toward the ground, right? So there are some things that, an action causes an effect. So very often we would like to know about causal relationships, whether they exist, how strong they are, what kind of magnitudes are involved. And so very often we'll be tempted when we find a relationship between two variables to assume that it's a causal relationship. A change in this is causing that change. But that's where we have to be really careful. So one example I like to talk about is related to a news article that I put in a folder in the content section. In the readings folder, there's a subfolder about news articles. So there's a study out of Denmark, and Denmark is a place that's special to me. But this study found that people who grew up, so if they lived their childhood years in areas that did not have a lot of green space, so using satellite imagery, they could kind of determine how much green space is nearby where you lived when you were a kid. And they found that people who grew up in areas that did not have a lot of green space, that variable was correlated with a higher incidence of mental illness as those people grew up. And so looking at them years later, those people are more likely to have addiction issues, they're more likely to have depression and anxiety, to be on medications to treat mental illness. So what does that mean? There's a relationship between growing up in an area without a lot of green space and having a higher likelihood of mental illness when you're older. So if it's a causal relationship where a lack of green space is causing people to develop mental illness later in life, well, that's a really important thing for us to know, right? That would have some very strong policy prescriptions. We would want to create as much green space as possible. If a lack of trees and grass and other plants nearby when you're young messes up your mental development in some way, that's really important for us to know, because mental illness has huge costs on both individuals and society, and we want to prevent it, right? So if we can prevent it by planting a whole bunch of trees, then great. That's important for us to know. Now, is that a causal relationship? We don't know. So the study found a correlation between these two variables. But a correlation is not causation. We might assume that it's a causal relationship. You may have prior beliefs that make it a very convincing narrative for you that growing up with a lack of green space nearby may cause you to develop mental illness later in life. That might ring true to you, and so you may say, yeah, I think that's a causal relationship. But the numbers don't actually tell us whether it's a causal relationship or not. They tell us that there's a correlation. There's some relationship between these two variables. But as we'll see, it could be a causal relationship flowing in that direction. It could also be a causal relationship flowing in the other direction, potentially. So if people who have more mental illness are more likely to move to places that don't have a lot of green space, we would see the same sort of statistical relationship. We would still see that correlation, even if it's the other direction, that mental illness causes people to live in places without a lot of green space. Now that may not sound too plausible for you, and actually in this study, that's something they were kind of concerned about, aware of, and tried to set aside by saying, okay, we're looking at green space many years ago when you grew up. We're looking at mental health outcomes several years later, and so it's unlikely that my mental health now is going to cause me, it's impossible, unless I have a time travel machine, it's impossible for my mental health now to cause me to move to a place with a lack of green space back when I was a kid, right? It might cause me to move in some pattern like that now, but it can't make me move that way when I was a kid. So we can actually rule that one out here. But there's some other stuff that's potentially going to get in the way of us saying a lack of green space causes mental illness later in life. There are things we call omitted variables. So there's other stuff going on, right? The world is a complicated place. And so there are other things that we may not be focusing on that may actually be related to both of the things that we're looking at and might be driving the relationship, meaning it's not a causal one. So for example, there may be relationship between income, money stress, poverty, and both living in a place that doesn't have a lot of green space and having mental health outcomes, higher likelihood of mental illness, addiction, things like that. Something like poverty is quite stressful, very stressful. And so if you are living in a concrete jungle because it's the only place that you can afford to live, then maybe that poverty actually explains both why you're living in a place without a lot of green space nearby and why you have mental health outcomes that look different later on in life. So it's not actually that a lack of green space is causing the mental illness, it's poverty causing both of those things, right? And so if we're focusing on a relationship between two variables, but there's something else that's actually driving the relationship, then if we suggest that changing the amount of green space is going to solve the problem, we're going to miss the boat, right? Because it's not actually the lack of green space, it's the underlying poverty. And so unless we address the underlying poverty, the real causal relationship, then we would be missing out on the change in outcomes that we were hoping for all along. That's why it's so important to understand relationships and why it's so important to keep in mind correlation does not mean causation. Sometimes there's a causal relationship between things we're looking at that are correlated. The statistics can tell us whether things are correlated. We'll spend time putting together these models, helping figure out complicated relationships, setting aside lots of other things going on in the world, focusing on a relationship between two particular variables we're interested in. But even when we've done that, we have to be careful about implications. What kind of relationship is this? Is it a causal one? And if not, what does that mean for policies we may want to recommend? So we're going to start this new section with that kind of big overview caveat that we need to be really careful with these tools because we can find stuff and run with it, but that can lead us down some dead ends and even be outright misleading. There's another article in that folder about wearing eyeglasses and contracting COVID-19. So they've found a correlation that people wearing eyeglasses are less likely to contract COVID-19 than people who are not wearing eyeglasses. So there's one that look at and try to think to yourself, is there some evidence here of a causal relationship or not? What have they done to try to address that? What would they like to do to sufficiently address the nature of the relationship between these two things? That's kind of where we're going, and it's important. So thank you guys. Have a good and safe weekend. I will see you next week.